in this problem, we're supposed to find the values of x that give f of x is equal to 3. And to solve this problem, it's really important to remember that when you look at the function notation f of x, that x on the inside of the function is a domain value. It's the input. And the 3 that you have on the outside is a range value, which we're going to think of as the y. So in this problem, we're told that f of x is equal to 3, which means the y value is 3. I'll get 3 for f of x is equal to the square root of 3x plus 7 minus x. Be really careful not to substitute 3 in for x and then calculate the value of the function. We are trying to find the value of x that gives f of x is equal to 3. When you look at this equation, it's a radical equation. So I want to isolate the radical. I'll add x to both sides. I'll have 3 plus x is equal to the square root of 3x plus 7. And then to get rid of the radical, I need to square both sides. On the right-hand side, I'm just going to get 3x plus 7, because the square root is undone by squaring. And on the left-hand side, be really careful. When you square 3 plus x, you're not going to get 9 plus x squared. You should write the binomial 3 plus x twice, and then distribute to simplify the left-hand side. When you simplify the left, you're going to get x squared plus 6x plus 9 is equal to, on the right, 3x plus 7. From here, this is a quadratic equation, so I want to get equal to 0 on the right-hand side. I'll subtract 3x from both sides. 6x minus 3x is 3x, and I'll subtract 7. 9 minus 7 is 2. And when I look at this, I could use the quadratic formula, but x squared plus 3x plus 2 factors pretty nicely into x plus 2 times x plus 1. And then from here, I can set each of the factors equal to 0. X plus 2 is equal to 0, gives x equals negative 2. And if x plus 1 is 0, then x will equal negative 1. So I need to be really careful now, because this started as a radical equation, and there's a possibility that one or both of those roots might be extraneous solutions. They might not make the equation true. So I need to do a check on both of those. When I do that, for x equals negative 2, I'll get 3 is equal to the square root. 3 times negative 2 is negative 6, minus the value of x, negative 2. Negative 6 plus 7 is 1, square root of 1 plus 2, and that's going to equal 3. So x equals negative 2 will check. I also need to check x equals negative 1. 3 must be equal to the square root of 3 times negative 1 is negative 3, plus 7 minus a negative 1. Inside the radical, negative 3 plus 7 is 4. Subtracting negative 1 is the same as plus 1, adding 1. And then the square root of 4 is 2. 2 plus 1 is 3. So this will check as well. Because of that, both of these solutions will work, and my solution set is negative 2, negative 1.